Alright, the first word is factorial. This little exclamation mark is called a factorial. It basically means, 5 factorial means start with 5 and decrease by 1 each time, all the way down to 1. That's what 5 factorial means. It means start with the 5 and decrease by 1 each time and then multiply it all. When you multiply all this, you get 20. 20 times 6 is 120. You basically just multiply all that, you get, in this situation, 120. So a exclamation mark is called a factorial, which means you multiply a series of numbers, starting with that number, decreasing each time. Permutations deal with order, and it'll make sense once we get into word problems. But a permutation, say you have 5p2. That means I want 2 out of 5. And it'll make more sense later. But basically, the formula to calculate it, n is the first number, r is the second number. So n is the first number, so it's going to be 5 factorial over n minus r, so 5 minus 2 factorial. You just follow the formula. By the way, you're not going to have to memorize this formula. I have a shortcut that's way easier. But you need to know the formula once in a while because there's weird questions where you need to know it, but I have a better way of doing it. Anywho, this whole calculation thingy, 5 factorial, like we said, is that. And what's 5 minus 2? Isn't that 3 factorial? So wouldn't that be 3 times 2 times 1? Are we okay so far? 5 minus 2 is 3, so 3 factorial. Do you see some cancellations? What's your answer? 20. And I'll show you in a little bit what this means in words. But for now, just kind of, there's a formula you kind of got to follow. Okay. Now, I'm going to do 5c2. 5c2 looks a lot like 5p2, but it has this extra r factorial. So mathematically, it would be 5 factorial over, what's r? 2 factorial. And then what's n minus r would be 5 minus 2 factorial. Again, I just plugged in my n, my r. I plug it into this formula. This formula is a shortcut, and I'll talk about it later. Anywho, this gives you 5 times 4 times 3 times 2 times 1 over 2 factorial, which is 2 times 1. And then that's a 3. So 3 factorial is 3 times 2 times 1. I'm sorry if I'm going too fast. But it'll make more sense once you see the whole thing. Are you okay with these canceling? Are you also okay with this 2 canceling 4, leaving you a 2? So my answer is 10. Alright. Combinations, permutations. These do with order, these do with unordered. We'll talk about that. Okay, let's just solve this factorial problem. 8 factorial over this. Let's multiply it all out and do some cancellations. 8 factorial will be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over, what's 4 factorial? 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. Okay. Do you see how these cancel? What is 3 times 2? Doesn't that equal 6? Won't that cancel with the 6? Won't 3 times 2 cancel with the 6? Got it? How about 4 and 8? Does 4 cancel with the 8, leaving you 2? 4 goes into 8, leaving you a 2. Does a 1 ignore the 1? Divide by 1, doesn't matter. So we now have 2 times 7 times 5 times 4. Oh, I'm stupid. The 4 would cancel with the 4. Okay. Anyways, 2 times 7 times 5 times 4 would be, it looks like 14 times 20, which looks like 280. That's a long, it's just showing you how to mess with factorials without a calculator. You write them out and you look for things that cancel. I made a mistake. The 4s would have canceled. I went over here and shrunk the 8. I didn't notice it. Okay. Now, for 7p5, you could do this formula right here. Let me show you a shortcut. 7p5, what that's saying technically, 7p5 is saying do 7 factorial, but only do the first 5 spots. Meaning 7 factorial, 6, 5, 4, 3, you stop. Look up here. Look at 5p2. Didn't that say start with 5 but only do the first 2? Because didn't the rest of them cancel out? Isn't that a lot easier? Is it easier than writing this big nasty? Isn't it easier to just think 5p2 means start with 5 factorial but only do the first 2 numbers? 7p5 means start with the 7 but only do the first 5. A lot easier. Yes, this is a nasty number and I'm an idiot for choosing something so big, but that's big. Oh crud. That's 42 times 20 times 3 is 60. And it's 2520? Okay, that's a big number, but is this a little bit easier to deal with? Okay, next. 6c4, see what I said here for 6c4? This is a lot easier to deal with right here. It's a shortcut. Instead of doing this whole rigmarole, if we just make 6c4 6p4 over 4 factorial, meaning 6c4 is going to be 6p4 divided by 4 factorial. It's a lot shorter than dealing with this formula. For instance, 6p4, what did we say that meant? Well, isn't that 6 times 5 times 4 times 3? You start with 6 but go 4 terms. 4 factorial, isn't that 4 times 3 times 2 times 1? That is 6p4, that is 4 factorial. That one cancels, anything else? The 2 will cancel with the 6, leaving you 3. So I now have 3 times 5 over 1, which is 15. I'm kind of going fast. Now, 4p3. Another way of writing 4p3 is 4 times what? 3 times 2. Don't we start with 4 and go 3 terms? How do you rewrite 6c2? Well, 6c2 is 3 times 2. We don't go all the way down. We do the first 2 terms of 3, and we divide by 2 factorial. And then we're going to get these 2 numbers and subtract them. So I have 12 times 2 is 24. I have 6 divided by 2, which is 3. My answer is 21. Alright. That's dealing with permutation combinations.